Hello students, my name is Neha Yadav and I am assistant professor in Noida Institute of Engineering and Technology. Today I am going to discuss on topic that is liquid crystals and glassy state. It is from Physical Pharmaceutics belonging to code BP302T. In earlier classes, we have already discussed about the various types of states of matter. So, in continuing to the same, I am continue with the next topic of our this chapter, that is liquid crystals and glassy state. So, first of all, I would like to explain what is crystal. What do you mean by crystal? So, crystal is a solid material which is constituent of either such as atom, molecules, ions, and they are arranged in a ordered microscopic structure. They are known as crystals. So, in this we have the state of matter have been discussed thus far. In this chapter, which is like gas, we have already discussed liquid as well as solid state in our previous class. So, today we are discussing the fourth state of matter, that is liquid crystalline state or mesophase. Now, again, what is mesophase? Mesophase is that thing when there is it is also a kind of a state of a matter, but it is an intermediate between a solid and a liquid state. So, what do you mean by mesophase? Mesophase are those which is the also a state of a matter, but it is the intermediate between solid and your liquid phase. For example, if you ask about the example, then I would say gelatin is the example of mesophase. Okay. So, next, the term liquid crystal is an apparent contradiction, but it is useful in a descriptive sense because material in these states are in many ways intermediate between the solid and liquid state. That what I already told you, that intermediate between solid and liquid state is termed as mesophase, which we already discussed in the above topic. So, for example, liquid crystal possess the property of mobility, okay, and rotation, and thus can be considered to have the flow property of a liquid. So, on the other hand, these are also possess the property of birefringence, that is a property often associated with the solid crystal. So, in this, what do you mean by birefringence? So, birefringence is an optical property of a material. What is birefringence? It is an optical property of a material having a refractive index, okay, having a refractive index that depends upon the polarization and the propagation of direction of light. तो जो direction होगी light की वो किस propagation से as well as कितना ज़्यादा depend करेगा refractive index पे will give you the birefringence. In the light passing through a material is divided into two components with different velocities and hence their refractive indexes. So, the velocity we discussed like what is the propagation and the polarization. It possesses characteristics both in the form of liquid and a crystalline solids. So, in liquid crystalline solid state, the molecules are held in a position by intermolecular forces. So, what is this? Like in crystalline solid state, are molecules which are there in any kind of like in solid or in liquid state, they are held in position when they are arranged in a particular position or they are held together in a position that is due to the intermolecular forces between the molecules or the atom in that solid state or either in that liquid state. So, the particles in a solid move, but cannot cross each other because the attraction of neighboring atom or molecule is too stronger to overcome. So, we are talking that molecules are held in a position by intermolecular forces. So, the particles if they are in solid state, बट दे कैन नॉट क्रॉस ईच अदर. पार्टिकल्स जो सॉलिड स्टेट के होंगे वो एक दूसरे को क्रॉस नहीं कर पाएंगे. क्यों? बिकॉज जो नेबरिंग एटम या नेबरिंग मॉलिक्यूल है वो उनसे ज्यादा स्ट्रॉन्ग है, तो वो उसको उसके ओवरकम नहीं करने देता है. दे आर वेरी स्ट्रॉन्ग इनफ. ओके, सो in this the liquid state the molecule moves to the random position. इसमें क्या है लिक्विड स्टेट में? सॉलिड में क्या है? सॉलिड में मॉलिक्यूल्स जो हैं आपके वो इंटरमॉलिक्यूलर पावर्स की वजह से एक फिक्स्ड पोजीशन में, इंटरमॉलिक्यूलर फोर्सेस की वजह से फिक्स्ड पोजीशन में इकट्ठे हेल्ड है. बट जब उसमें होता क्या है, मूवमेंट होगी अगर सॉलिड में, ठीक है, तो वो एक दूसरे को क्रॉस नहीं कर पाते, वो इंटैक्ट रह जाते हैं. क्यों? क्योंकि जो उनका नेबरिंग एटम और मॉलिक्यूल होगा उसमें स्ट्रॉन्ग पावर है. ठीक है, बट लिक्विड में क्या हो जा रहा है? इट इज द सेकेंड अपोजिट थिंग. लाइक इन लिक्विड मॉलिक्यूल मूव्स रैंडमली टू द पोजीशन. दे आर नॉट हेल्ड इन अ पर्टिकुलर पोजीशन, और एक इंट्रामोलिकुलर फोर्स की वजह से वो एक साथ नहीं, वो रैंडमली मूव कर रहे हैं इधर उधर. बट द लिक्विड क्रिस्टल स्टेट, the increased molecular motion overcome molecule remains bound by stronger forces. Then solid का आपको पता चल गया, liquid का पता चल गया. Now we are talking about the liquid crystals. इसमें क्या है कि जो molecular motion है वो ज़्यादा हो जा रहा है. जब molecular motion ज़्यादा हो जा रहा है तो molecules क्या कर रहे हैं, वो एक दूसरे को overcome करके और जैसे थे वैसे ही रह जा रहे हैं. Remains bound by stronger forces. ठीक है, और stronger forces are the intermolecular forces in the atoms or in the molecules. This produces a molecular arrangement where the molecule is a layer by within each layer the molecules are arranged a random position. So in liquid crystals इसमें क्या होता है, जो molecules होते हैं वो हमारे क्या होंगे, arranged रहेंगे. ठीक है, लेयर बाय लेयर. ठीक है, लेयर बाय लेयर, लेयर्ड अरेंजमेंट, वन बाय वन विथ ईच अदर, और रैंडम पोजीशन होगी. दे टेक रैंडम पोजीशन इन देयर अरेंजमेंट. द मॉलिक्यूल्स कैन स्लाइड वन अराउंड द अदर एंड लेयर कैन स्लाइड ओवर द अदर. तो या तो हो सकता है कि सिंगल मॉलिक्यूल, एक मॉलिक्यूल के ऊपर एक मॉलिक्यूल, ऊपर एक मॉलिक्यूल इन द फॉर्म ऑफ लेयर अरेंजमेंट होगा, या कंप्लीट एक लेयर overcoming to the another layer, overcoming to the another layer, overcoming to the another layer. Okay, this is our liquid crystal. So there are two main types of structures of liquid crystals. Okay, now we are discussing the types of liquid crystals. So basically there are two types of structures of liquid crystals, and they are mentioned like symmetric we can say and pneumatic we can say. So what is symmetric? Symmetric are those in which the arrangement of molecule or the structure which appear is like as a soap or a grease like. Okay, whereas in pneumatic it will look like as a thread. Okay, thread like structure will be there in pneumatics, and in symmetric soap like structure or your grease like structure. Okay, so in symmetric state molecules are mobile in two direction and show rotation about one axis. What is this? What do you mean by this? In symmetric, that one structure of liquid crystalline is symmetric. एंड सिमेटिक कैसे होते हैं आपके, सोप या ग्रीस की तरीके के. अब सिमेटिक स्टेट में होता क्या है, मॉलिक्यूल्स जो होते हैं वो दे आर इन मोबाइल फेज. मोबाइल फेज मीन्स दे आर इन मूविंग. ओके, दे आर इन द position or they are in the moving phase. So when they are moving in two directions. Okay, they are moving in two directions and shown rotation about one axis. मान लीजिए कोई हमारे पास एक particular axis है और इसमें दोनों direction में हमारा जो molecule है वो move करेगा. तो the movement of the molecule is it is rotating about a particular one axis. एक ही axis पे वो rotate करता रहेगा. Like you can say this is the rotational movement of that molecule. So in symmetric, what is the thing? Molecules are in the mobile state, okay, that is moving state, and they moves in two directions, okay, and they rotate on about one axis. एक ही axis पे दो direction में, either it is likewise clockwise or anti-clockwise, but they moves in only one axis. So in the pneumatic. Now we are talking about the second type we are discussing two types. The second type is a pneumatic state. What is pneumatic state? In this, molecules are in mobile in 3-dimensional, like here molecule are there in the moving phase, but they can move in 3 dimension. Okay, they can move in 3 simultaneously directions. The third type known as the cholesterolic crystals. Okay, what is the third type? Third type is, main two types are there. What is symmetric and second one is pneumatic, and third is another type which is the cholesterolic crystals, which exist but may be considered as a special case of pneumatic type. जो third type है हमारा वो cholesterolic crystals हम बोलते हैं, ये particularly हमारा pneumatic जो second type है ना, जिसमें molecule 3 dimension में move कर रहा है, उसी में fall करता है. Moving to the next, the liquid crystalline state is found widespread in nature, in nerve, in brain tissues and blood vessel. Where we can find the liquid crystals, we can find such kind of crystals in the natures, like we can find them in our nerves, in brain tissues and are in blood vessels also. Erythrosclerosis is though to result from the deposition of liquid in the liquid crystalline state on the walls of blood vessels. Now, what is the thing that is erythrosclerosis? What do you mean by this? It is referred to as the buildup of fat or cholesterol or any other substance on your artery walls. Okay. So, the deposition of either fat or cholesterol or any other substance on your artery walls is to be termed as erythrosclerosis. It is though result in the form of liquid in the liquid crystalline state, okay, on whole blood vessels. So, the three components of bile, that is cholesterol, bile salt and water, when present in a definite proportion, can result in the formation of symmetric crystals, and these may be involved in the formation of gold stones. So, what is this? If these three components, what are the three components? If bile, cholesterol as well as bile salt, ठीक है, as well as water, when present in a definite proportion, okay, defined proportion में जब ये तीनों चीज़ें present होती हैं, तो ये क्या करती हैं? एक symmetric crystals form करती हैं. Symmetric crystals क्या हैं? They are the crystals having a two directional movement on a particular axis, and they may also involve in the formation of gallstones. So, certain symmetric crystals are believed to be involved in the stabilization of emulsion and have been used in the solubilization of water insoluble material. तो हमारे बहुत सारे symmetric crystals जो होते हैं, उनको हम क्या करते हैं? We involve them in the stabilization of emulsion. Emulsion की stability के लिए, to make our emulsion stable, we use certain symmetric crystals, and then it is also used for the solubilization of some amount or some components which are not insoluble in water. वाटर इनसॉल्युबल अगर कोई मटेरियल है, तो अगर हम उसको अपने इमल्शन में यूज़ कर रहे हैं, तो हम सिमेट्रिक क्रिस्टल्स यूज़ करेंगे, सो दैट वी कैन हैव द स्टेबिलिटी एज वेल एज द सॉल्युबलाइजेशन ऑफ अ पर्टिकुलर component. Now, moving to the next, we have types of liquid crystals. So, what are the types of liquid crystals? We have first thermotropic liquids. Okay, what is thermotropic liquids? Basically, the liquid crystals are said to be thermotropic if liquid crystalline property depends upon the temperature. तो जो हमारा सबसे पहला टाइप है इसमें, टाइप ऑफ लिक्विड क्रिस्टल में, दैट इज थर्मोट्रॉपिक. व्हाट डू यू मीन बाय थर्मो? थर्मो मीन्स डिपेंडिंग अपॉन द टेम्परेचर. सो इन दिस इट इज, और these are the type of anisotropic liquids, okay, that possess a mesophase. ये क्या है, एक anisotropic type of mixtures हैं जो mesophasic property को possess करते हैं, ठीक है, with certain range of temperature. ऐसा नहीं कि सभी, लेकिन एक certain range of temperature के बाद they'll produce a mesophasic property. Mesophasic property means, mesophase means there is a state of a matter which is an intermediate between a solid and a liquid, that is mesophase. So thermotropic liquids are those liquids which depends upon the temperature but on a particular range of a temperature. Now in this we have two things like pneumatic liquid crystals and symmetric liquid crystal. We already discussed that. Here the molecules, mesogens, have no positional order but they have long range of orientational order, okay. Like in symmetric liquid crystal, what is this? In this the mesogens have both positional order and orientational order. So in this pneumatic, if we talk about pneumatic liquid crystal, they are transparent or translucent in appearance, okay. Appearance mein they are being a transparent or a translucent liquids that cause the polarization of light, okay, that produce the polarization of light waves. So what is that symmetric liquid crystals? It consists of flat layer of ligands, okay, which helps the molecule with their long axis orientation which is perpendicular to the plane of the structure, okay. So pneumatic and symmetric we already discussed. What is symmetric, what is pneumatic? Pneumatic और symmetric अगर types of crystals में हम बात करते हैं तो they are the two main types and third one is cholesteric type, okay. तो symmetric में आपने इससे पहले भी देखा कि क्या होता है, दो जो हमारे molecules होते हैं they will move in the two direction on a particular axis, और आपके pneumatic में क्या होता है, three dimensional movement होती है, ठीक. Like pneumatic crystals में they are transparent and translucent type and symmetric they are very flat layered, okay. So next is cholesteric type crystal. The cholesteric phase can be defined as a special type of pneumatic liquid crystal in which thin layer of the parallel mesogens have their longitudinal axis rotated in the adjacent layer at center or a certain angle. So next we have type of a liquid crystal, next is lithotropic liquid crystal. Liquid crystal which are prepared by mixing two or more substances of which one is polar molecule is known as lithotropic liquid crystal, okay. What is lithotropic liquid crystal? ये वो होते हैं जिसमें क्या हम दो substance को mix करते हैं, mixing by two और more than two substances are there also, जिनमें से एक जो होगा वो हमारा polar molecule होगा, ठीक है. Then it is known as lithotropic liquid crystal. For example, we have soap, okay. Now next we have glassy state. What is glassy state? Glass is considered to be a non-conducting transparent solid. It is actually a type of a solid matter. It neither be considered as a typical solid nor a typical liquid. So the atom and molecule in most solids are arranged in an orderly manner, whereas in glassy material these are highly disordered, okay. Glassy materials do not have specific melting point, but these slowly and gradually liquefy on heating. So glassy materials का अपना कोई भी specific melting point नहीं होता है, ये कैसे slowly melt करना शुरू करते हैं जैसे कि हम धीरे धीरे टेम्परेचर को बढ़ाना शुरू करते हैं, okay. Structurally glassy material can be considered to be made up of random selection of polyhedral molecule linked together at their certain corners. So glass is a non-equilibrium, non-crystalline state of a matter that appears solid on a short time scale but continuously relaxes towards the liquid state. So glass is a non-equilibrium, non-crystalline condensed state of matter that exhibits a gas transition. the structure of glass is similar to that of their parent supercooled liquids, that is SCLs, that is supercooled liquids, and they spontaneously relax towards the supercooled liquid state. Their ultimate fate in the limit of infinite time is to crystallize. So, what are the characteristics of glassy state? There are some characteristics of glassy state mentioned here, like it has been transparent, it has particular solid appearance, it should be brittleness, and molecules have no order structure. In glassy state, the molecules have no order structured, okay, because as it is melt up gradually, okay, as we increase the temperature, it decreases. So, the structure moiety will changes. Volume of the system is larger than that of crystalline system with the same composition. Now, here are some properties of glass, like mechanically strong, it should be mechanically strong, it should be hard, it has a good elasticity, it should be chemical corrosion resistant, it possesses thermal shock resistance, it is heat absorbent, it is optical, having a optical property also, it absorbs lights also, and electrically insulating. So, these are the properties of a glass. So, these systems are often referred to as amorphous and supercooled liquids. So, what is amorphous solids? They are disordered. Example is glass. Disorder means the arrangement of molecules, okay, is not in the ordered form. They arranged in a disordered, means any manner, haphazard manner, okay, that is known as amorphous, okay, means the movement or the structure is not in a particular sequence or in a arrangement, that is known as amorphous. That is why we are saying disorder arrangement of a particular solid. And supercooled liquids are rubber, leather and syrups. Glasses are generally formed by melting crystalline materials at very high temperature. How glasses are formed? They are generally formed by crystalline materials only, but when we heat the crystalline material at very high temperature, we will get glasses. So, when they melt, okay, then they comes to cool and the atoms are enclosed in a particular random, okay, randomly, जैसे जैसे जो cool होता जाएगा वो आके stick होता जाएगा, that's why it is disordered, है ना, मॉलिकुलर वेट या उसके मोइटी के अकॉर्डिंग वो आके अटैच नहीं कर रहे हैं, जो जैसे कूल होता जा रहा है वो ऐसे आके अटैच होता जाएगा, दैट वाई इट इज डिसऑर्डर स्टेट बिफोर दे कैन फॉर्म अ परफेक्ट क्रिस्टलाइन अरेंजमेंट. So, glassy state are also various type. The first type is, it is characterized by the cessation of a vibratory movement of rotation of molecules in a defined, that is critical temperature region. This result in stabilization of the chain structures of rigidity associated polar molecule, that means by dipole moment. Okay. So, the second type is, it consists of organic glassy polarization products. These glass in the stabilized state have a fibrous structure, okay, the structure is like fibrous and it of rigid valencies, bonded carbons atom with small leather branches in the form of hydrogen atom or more complex radicals. So, this is our second type. Then third type, we have the most extensive type of glass state consists of refractory organs, compounds of multivalent elements. These glasses in the stabilized state have the most thermostable chemical structures in the form of dimensional atomic valency bonded spiral network. Then here is a one question like, what is glass transition temperature? Okay, what is glass transition temperature? It is the temperature below which polymer is hard, okay, the temperature at which the polymer is brittle and above which it is soft, okay. It is called as glass transition temperature. What is glass transition temperature? The temperature of a polymer, okay, temperature not of a polymer, but temperature below which a particular temperature below which a particular polymer is hard and brittle, okay, but above this it will be soft, okay. This is called as glass transition temperature. If I will say the example again, I will talk about the gelatin. Like gelatin, if it is solid, okay, if you keep here in the form, it will be in solid form, okay. Hard bhi hoga, it will be brittle, okay. But when you dissolve it in a warm water, it slowly start mixing or dissolving in the water, because as after a particular temperature it will start melting, okay. Or if you won't dissolve in water, if you will take a solid piece of a gelatin and keep it in the microwave of a temperature around 40 to 50 degree temperature, then it start in the form of gelation, like it press easily, it will become soft in a very soft manner. So, before that transition temperature, below that transition temperature, that polymer example I have given, that is gelatin, it will be hard and brittle, okay. But as it moves to above that temperature, it will soften, okay. And if you again increases the temperature, it will completely melt out, okay. So, to hard or brittle state is called as glassy state, and the soft and flexible state is called as the rubber state, okay. Now, this is our glass transition temperature. You can see here, like the temperature below which a polymer is hard, brittle, and above which it is soft in glass transition temperature, which I already cleared you. The hard and brittle state is called as the glassy state, and the soft flexible state is called as the rubber state. Now, in this representation of graphical, here you can say this is a glass transition, this is the glass transition phase here, okay. This is the stiffness modules and this is the temperature here. This is the particular temperature, glass transition temperature. If the molecule, if we increases the temperature, initially it was hard and brittle. If we increases the temperature, it will start in rubbery state, rubbery flow, and then in viscous flow. This was showing in the temperature. Here temperature was here, so likewise it is moving like this direction. So, initially we have our polymer in a hard, okay, in a solid, hard or a brittle form, because where the temperature is below the polymer, okay. So, where the temperature is below the polymer, it will in the state of what? Hard and brittle. As well as we increases the temperature, the transition temperature of that particular glass, it start in the form of rubbery state. Then if it again increases the temperature, it start in the rubbery flow, okay, and lastly it moves to the viscous flow. So, in this we discussed the three things, that is about like glassy state. तो glassy states हमारी amorphous और सुपर कूल्ड लिक्विड्स होते हैं, एंड इसके बाद टाइप्स में हमने पढ़ा फर्स्ट टाइप, सेकेंड टाइप, एंड वी हैव द थर्ड टाइप, ओके. ये तीनों टाइप्स हो गए. आफ्टर द थर्ड टाइप we move to the transition temperature. What is the transition temperature is there, and these are the references for the whole content of our this lecture, like of the solid, liquid crystalline and your glassy state. So, with this I would like to conclude my lecture for today on the topic liquid crystals and your glassy state. Thank you and have a nice day.